Alright, so we have just finished our exponentials unit and we are going into logs as well. We will still use stuff from the previous unit, but we are going to be adding in a lot of new stuff. So the first thing we're going to cover is actually how we're going to change forms. So what we can do is we can actually start with something in exponential form, and we can go from that to logarithmic or log form. But you also need to know that we can start from log form and also go back to exponential. We're going to use the same rules and the same forms to do that. So for exponential form, we have something like a base of b with an exponent of y is equal to something x. This is what we've dealt with so far. So with log form, we first start off with the word log. We still have that base of b. Next to that, we have the x, and then it's equal to y. So if you notice, we still use the same variables for each one. And remember, we can go back and forth between exponential and log, and we're going to practice rewriting both in just a second. It's super important here just for you to know about logs. This base b will be a number, but sometimes there will not be a base written. So if there is no base, you have to assume it's 10. So if there's no number written there with the log, its base is 10. Now the easiest way that we're going to do this, or to think about this, is if we're going from log to exponential, we're going to do something kind of like a loop around. If you notice, if I start at b, go up to y, and then back to x, that gives me b to the y equals x. So if you're going from log to exponential, you want to loop around. We'll go from exponential to log in just a minute. There's not really a cool trick, but we will practice it. It's the same form. So we're going to do a few examples together. You're going to try some on your own. In these 4 examples, I'm asking you to express the logs as exponentials. So we're going from logarithmic form to exponential form. So our first example reads, log base 3 of 81 is equal to 4. And so I'm asking you to go from log form to exponential. So your final answer should not have any logs in it. So remember, I told you if we're going from log to exponential, we're going to do that loop around. So I'm going to start at the base, go to the other side of the equal sign, and end up next to the base. So then I would rewrite this simply as 3, what came next in our loop. So we started at 3, we went to 4, so that tells me that's my exponent, is equal to, and when we finish, we ended up at 81. So 3 to the 4th is equal to 81. You could plug this into your calculator as well and check out that this works, but this is how we would go from log to exponential form. We're going to do one more together before you try some on your own. So again, I'm going to start at the base. I'm going to loop around to the other side of the equal sign. So I have 3 to the negative 2 is equal to, and I'm going to finish that loop around and end up next to the base. So I have 3 to the negative 2 is equal to 1/9. We just did our exponentials unit, so you should know that 3 to the negative 2 is in fact equal to 1/9. So the first example you're going to try on your own is log base 2 of 8 is equal to 3. Remember, I want you to write this as an exponential. After doing example 3, you should have gotten 2 to the 3rd is equal to 8. Your second example I want you to rewrite is log base 10 of 1 over 100 is equal to negative 2. And for this one, you should have gotten 10 to the negative 2 is equal to 1 over 100. So these next 4 examples that we're going to do, we're going to go in the opposite order. I'm going to give you exponentials, and I want you to write them as logs. So that means your final answer will have a log in it. So I've gone ahead and written exponential and log general forms on the screen just so you can remember. Remember, b to the y is equal to x. In log form would be log base b of x is equal to y. So the first exponential I want you to rewrite in log form is 3 to the 4th is equal to 81. In this example, I am going to identify my b, my y, and my x. So my 3 is my b, that 4 is my y, and the 81 is my x. So if I wanted to write this in log form, I would first have my log. My b, or my base, is 3. My x is 81, and it's equal to my y, which is 4. If I wanted to check this, you could do that loop around again to make sure you got the original exponential. Now, if you can't remember all of that, example 2, I'm going to show you how to do a little bit different. So I have 27 to the 1/3 is equal to 3. So the number that has an exponent, that's always your base, and that's always the base of your log. So I have log base, and my base here is 27. It has the exponent. Now, when I'm going from exponential to log, if the numbers are touching in the exponential, they cannot be touching in the log. So that means I cannot have 1/3 right next to 27. It's going to be on the other side of my equal sign, and the only other number left is 3. Now, if I wanted to check it, I would do my loop around. I get 27 to the 1/3 equals 3, and that is what my original was. So you have 2 ways to do this depending on what makes more sense to you, and I'm going to give you 2 to try on your own. So example 3, I want you to rewrite 5 to the 3rd equals 125 in log form. When you do this, you should get log base 5 of 125 is equal to 3. In example 4, I want you to rewrite is 81 to the 1/2 is equal to 9. When you do that, you should end up with log base 81 of 9 is equal to 1/2. So we just did a very basic intro to logs, changing forms from exponential to log, and now we're going to talk about the actual evaluating of logs. There are 2 important things for you to know. The first is that logs are inverses of exponentials. What that means is that they undo each other, kind of like the square root and the quadratic squaring something. That's what logs and exponentials are to each other. You also need to know that logs with the same base as the exponential cancel each other. And that's what's really cool about them being inverses. They have certain properties that make them cancel each other out. So what I mean by that is I'm going to ask something like evaluate, and I'm going to give you log base 3 of 243. Now, I'm telling you that the base here is 3. That's just from knowing what the form of a log is. By telling you that, I'm also telling you that this next part, this 243, needs to be rewritten in that base. So this goes back to your exponentials. We made that chart, but here you have to be able to figure out what it is. So if you have to, you just start guessing and checking. You go 3 to the 1st, 3 squared, 3, 4, all of that until you get to 243. When you do that, you end up with log base 3, and I learned that 243 is the same thing as 3 to the 5th. Now, that second bullet point said logs with the same base as the exponential cancel each other out. So I have log base of 3, and it cancels out my exponential base of 3. So I find out that when I evaluate log base 3 of 243, it's just equal to 5. It's equal to that exponent that's left over, as long as the log and the exponential part have the same base. So the first example we're going to do, and the second you'll do on your own, I want you to evaluate log 9 of 1 over 81. So like I said, I'm giving you the base of 9. I'm telling you this next piece needs to be written with the base of 9. So this goes back to thinking about what your exponents are. So I could break it into log base 9 of 1, and I know that 81 is 9 squared. But I can't have this fraction. So remember, we have to move it to the top. And when we move stuff to the top or move stuff to the bottom, that makes its exponent have an opposite sign. So now I have log base 9, and instead of 9 squared, I'm going to have 9 to the negative 2. Remember, at this point, if your log and your exponent base are the same, they cancel out. So my final answer, log base 9 of 1 over 81, is just negative 2. All right, so number 2 is for you to try on your own. I want you to evaluate log base 10 of 1,000. So hopefully you rewrote 1,000 as 10 to the 3rd. The log and the exponential base are the same, so they cancel out, and you get 3 as your answer. So the last thing we're going to cover today is properties of logs. We had exponent rules for exponentials, and these properties of logs are like rules for logs. So they follow somewhat similar, and they're things that you have to follow. So we do have 3 properties that we're going to deal with. The first one is product, second is quotient, and the third is power. So starting off with the product, if you have something that is the log, there is a base, and you have two things being multiplied, which is what product means, so m times n. I can actually break that into log with the same base of m plus log with the same base of n. So if I have something being multiplied, it goes with addition. If I have something being added, I can change it into multiplication. And you'll see what that means in just a second. Now for quotient, if I have log base b still of m divided by n, because division is what quotient means. What I can break that down into is a log base b of m minus the log base b of n. So product, multiplication goes with addition, quotient, division goes with subtraction. And the last property we're going to deal with is called the power. So if I have something that's log base b and I have m to the power of p, I can actually break that into p goes in front. I still have the log of base b, and then I have that m. So what happened here was that exponent came into the front, and that's why the p is in front of the log when I break it down. So the reason we have to know these properties first off is because we're going to be doing two things with them. We could ask you to expand the logs or condense them. So if you were given expand, that means you're going to take something small and turn it into something big. You're going to be given one log and you're going to expand it into multiple logs. And the way we're going to do that is using those properties we just learned. You could also be asked to condense, which is just the opposite of expanding. So in this case, you'll have multiple logs, and we're going to ask you to condense them into a single or one log. So remember that expanding and condensing are just opposites of each other. So in these next examples that we're going to do, I'm asking you to expand the logs. So we're going to go from one log to multiple logs. I've put those properties up here on the screen just in case you forgot or have to reference back to them. So the first example I'm going to ask you to expand is log base 3 of 5 over x to the 4th. So remember, we're expanding, so we're starting with one log, and we're going to end up with multiple logs in our answer. I first need to decide which of my properties I'm going to use first. And if you look here, we have a division. And you need to remember that division signals quotient. So that means I need to take what I have, my fraction, my division, and turn it into subtraction first. So I still have my log base 3. And because we're given that, that's what each of our logs will have. They'll all be log base 3s. With the quotient, I take whatever's in the top, so that's 5 minus log base 3 of whatever's on the bottom, so x to the 4th. Now you may say, okay, I have multiple logs, I'm done, but we're not done here because we have this exponent up top. So when I look, it's not a product, so I don't have to deal with that. There's no more fractions, so I don't have a quotient. I do have to do this power rule first. What that means is I'm going to take this exponent of 4, and it's just going to be brought in front of the log it's directly touching. It doesn't go in front of every log. So I still have log base 3 of 5 because that one's done. But now I have minus, that 4 comes to the front, and then you still have log base 3, and since the x to the 4th lost its exponent, it's just x. This is your final answer. This log has been expanded. So in example 2, I'm asking you to expand log base 2 of x times y to the 3rd, all raised to the 4th. You kind of have to remember your exponent rules here because we need to get rid of the parentheses first. So to do that, I actually have to take that exponent of 4 and do my power of a power rule, which means I'm going to multiply the exponents. So I have log base 2, and I now have x to the 4th, y to the 12th. You have to remember when things are stuck together, they're being multiplied. So this actually looks like x to the 4th times y to the 12th. And when I look at my properties to use, I see that this is a product. So I'm now going to have some addition in my answer. So I'm going to take the first one, log base 2. I have x to the 4th plus log base 2 of y to the 12th. Now, just like the previous example, I'm not done yet because there are exponents in my answers. So remember, we're going to take those exponents and they're going to go directly in front of the log that they're touching. So I'm now going to have 4 log base 2, and since the x to the 4th lost its exponent, it's just x plus that 12 is going to come in front as well. And then I have log base 2 of just y. This log has now been expanded and you are done. So example 3, I want you to expand on your own. I want you to expand log base 10 of 4b over 7. So hopefully you got log base 10 of 4b minus log base 10 of 7. There's no exponent, so we're done. Example 4, I want you to expand log base 4 of 6z to the 3rd. Be careful here. Remember, anything stuck together is being multiplied. When you finish this, you should get log base 4 of 6 plus 3 log base 4 of z. Be careful of that exponent. Remember, it does have to come in front. Now, the last examples we're going to hit are going to go backwards, so we're going to condense these logs, which means we're going to have multiple logs, and we want to end up with only one log as our answer. So what we have here is 3, and then in parentheses, log base 10 of 20 plus log base 10 of 4. Just like our PEMDAS, we always want to deal with those parentheses first, though. So right now, I am focusing only on the inside. And if you go back over to your properties, the one with addition is your product. So I'm now going to go from having addition to something being multiplied. So I still have that 3 on the outside, but I have log base 10 because they both share that base of 20 times 4. Now I need to keep going because I'm not done. So I still have the 3 on the outside, log base 10 of, and then 20 times 4 gives me 80. I still have that 3 out in front, and so we're actually now going to do the opposite of the power rule. I'm going to take that 3 out in front. It's going to come up as an exponent. So my final answer will look like log base 10 of 80, and it has an exponent of 3. You can leave your answer just like this. I don't need you to plug in 80 to the 3rd. The second example that I'm going to ask you to condense into one log is 3 log base 7 of 5 minus 15 log base 7 of 8. We always want to check to make sure we do have the same base in our logs, and we do, so that tells us that we can condense it. Now looking at my properties, I have a subtraction sign, which means I'm going to be first dealing with the quotient, but if you notice, we also have these numbers out front. When I have those numbers out front and there's not parentheses like example 1, I have to move those first. So my numbers out front are now going to become exponents. So they're going to come up. And I'm now going to have log base 7 of 5 to the 3rd minus log base 7 of 8 to the 15th. Now there's nothing in front of the log, so I can continue on with my quotient rule. I'm going to take log base 7 because it's the same. I'm going to put 5 to the 3rd on the top of my fraction. And then I'm going to have 8 to the 15th on the bottom. You leave it just like this. There's only one log in my answer, so I am done. Example 3, you're going to try on your own. I want you to condense log base 4 of 7 plus log base 4 of 5. When you do this, you get log base 4 of 7 times 5, and then you should end up with log base 4 of 35 as your final answer. And the last example for you to try on your own, I want you to condense 2 log of x minus 6 log of y. When you're done, you should get log of x squared over y to the 6th.